In this video, you'll watch a live class of me explaining the applications of circular functions to my students. Enjoy. Recording has started. Okay, so this class is going to cover the applications of circular functions. So fundamentally what's happening here is we're looking at questions where we have an extended response style thing. There's a bit of a story behind what that circular function is detailing, and it's our job to take that information, convert it into either equations or key information that allows us to solve the circular function. So, very briefly, circular functions look like so, right? I've used a generic sine, could be cosine, unlikely to be tan. Usually there's a very few things that'll be tan related. And our goal is basically to solve all of these terms in here. The a, the n, the h, and the c. That'll tell us the rule of our circular function. Welcome, Michelle. Okay, so this is less of a step-by-step thing, more of a framework that I found tends to work best when trying to solve these kinds of equations. You can technically do things in almost any order. This just tends to be the easiest way of going about it. I've written it in terms of ease of information down to more difficult information to achieve. So we're going to look at this example here. It's detailing time between tides. The circular function is depicting what will be the height of a given tide for a given time. A whole bunch of information in there. We'll look at how we can digest that information into solving the particular terms of the circular function. Welcome, Pia. Okay, so first thing that tends to be easiest to solve for circular functions is identifying the period of the circular function. For those who haven't seen the graph of a circular function just yet, what I'll do is I'll quickly show you what that looks like. We won't get into too much detail on that, but more so just so you can see what they look like. Circular functions look like waves, for anyone who hasn't been introduced to that. This is what sine looks like. This is what cos looks like. Very brief. The idea being that these circular functions repeat in a certain duration. That is called the period of the circular function. So, in the context of our application style questions, welcome Shanji. In the context of our application style questions, the period is just going to be how long it takes for our given scenario to repeat once. And the piece of information that that is going to tell us that is, where is it? Yeah, time between high tides is 12 hours. Right, so if you think about tidal waves, they go from high tides to low tides to high tides to low tides, and that repeats over and over again. So when it says the time between high tides is 12 hours, it means one full cycle of tidal waves has passed within 12 hours. Hence our period, capital T, is going to be equal to 12. On an axis, that would mean this would be t equals 0, and this spot over here would be t equals 12. Any questions? Please put them in the chat. I'm more than happy to jump back. Now, there is an equation for calculating the period. The period of any circular function is 2 pi divided by n. And so if we know that the period is 12, then we can sub that into our period equation and rearrange for n. N being this term here. It's the coefficient that is either directly on the x or perhaps factored out, depending on how it looks. In this case from our question, n is directly on the t variable, which has replaced our x. So, pretty trivial. You were given one piece of information, told you the period, recalculate to get the n term from that. Next easiest thing is typically to find your vertical translation. In the context of circular functions, the vertical translation will always be the midpoint of that circular function. So if I go all the way down to what vertical translations look like, there's a +2 here. And what that means is, instead of being a wave from the center point, you now have a wave that is centered at y equals 2 instead of y equals 0. So our goal is to find the mid-level of our circular function by any means necessary. In the context of how you could solve it in application style questions, you could calculate it, right? If you're told the peak and the trough values, so that's going to be like up here and up here. So high tide and low tide in our case, if we had that information, we could just do the average of that. right? You'd add them two together and you divide by 2 to find the middle. In this case, however, we don't have both of those pieces of information, but we do have a statement here that says the average depth of the water is 5 meters. Average, midpoint, these are synonymous words, usually. There's a bit of a nuance to it, but point being is the keyword average is going to be talking about the middle of your circular function. If the middle is what we care about, then it's going to mean that our vertical translation B is going to be 5. Now I say B because that's what the question had it. Usually your vertical translation is a plus C. Doesn't really matter. Letters are letters. Okay, so to recap, we got N from our period. That was from this statement here. We got B directly from the next statement that followed. Average value of the river, of the height of the river rather. Next up is identifying, now I say the amplitude, but really I mean the A term. There is a mild difference between this value and the amplitude, and that is that this could be negative, but the amplitude will only ever be positive. So what that might look like, if we scroll to what reflections would look like, negative sign, normally sign would be up here and down here. It's been reflected. Now, the reason why I've specifically written in here that we need to fix things up is because with the information that we're given, we're only told the peak and the middle of our circular function, and there's no way to actually know whereabouts that occurred. To demonstrate the point, I'll go to the handwritten notes. Using the information that we currently have, we're told it's a, what do we have currently? So it's a sine wave, and it's got a B of 5, so mid-level of 5. We were told the maximum was, where is it? High tide is a depth of 8 meters. So highest possible value is going to be 8. And so there's a couple of ways you could do this. You could figure out this bottom value, but we'll look at that in a bit. One way of drawing a circular function might be like that. That peaks at 8, and it has a middle of 5. But an equally valid way of doing this, using the same values, is to peak just a little bit later. So instead of going up and then down, you could go down and then up. This still has a peak of 8, still has a middle of 5. And so with the information we're given, we can't tell which one this is. That's why we're just going to choose. We're going to make it up. We can fix it later. So a couple of ways you can calculate the A value. We can say the amplitude, but just be mindful, technically a bit of a different thing. You could do the peak minus the mid-level, which is what we have. We have the peak value of 8, and we have the middle value of 5. Or if you have the trough instead, you could do middle minus trough. So if we know what this value is, we could do this distance here. Both of those will give you a possible A value. My preference is to make it positive, just because positive numbers tend to be on the easier side. You'll see in the next step how we're able to quote-unquote fix what's going on. But okay, that's how you calculate the leading coefficient, that A term. Usually you would either have to, calculate it, either by looking at the difference between the peak and the middle, or the middle and the trough. So, to recap, we got N, we got B, we've got A. The only thing left is this piece of information in here. That is a horizontal translation. Would I say, got a question, would you say this is translated up 3 units and has an amplitude of 3 as well? Has it been translated? It's been translated up 5. This one has. So the vertical translation is our B term. It's this thing here. As for amplitude, you are right. Amplitude is 3. So maybe it was a bit of a typo, but the plus, yeah, accidentally wrote it. Okay. Yes, this will be a vertical translation, shifted up by 5, and it would have an amplitude of 3. Okay, that's that. Now, because we have this, this, and this, if we're able to get rid of the t and the h with some substituted value, the only thing left in this circular function would be epsilon, that horizontal translation term. And we can see that a little bit easier after we've plugged in all our information. Here was our b, here was our n, here was our a. If you had a value for t and a value for h of t, the only thing left would be this epsilon. Horizontal translations. You're pretty much always going to be solving those by subbing in a known point. So we have to figure out what piece of information in this question gives us a known point. And that's going to come here. At noon, there is a high tide. This is a function that describes the height of a wave with respect to time. So h of t. Height is your y, t is your x. Noon is a time value. High tide is a height value. We know that a high tide is 8 meters, and noon we can relate to what t is. T being the number of hours after noon. Anyone know how to interpret that? What would your t value be if I said it was at noon? What specific t value would you have? Yeah, t equals 0. Thanks, Cheyenne. I got that from direct message. Ideally, if you guys can put it in the actual group chat, that way I don't look like I'm talking to myself. That'd probably be better. Yes, it'd be 0, because if t is the number of hours after noon, then at noon must be 0 hours after noon. So that's what we're going to do. We sub in our t equals 0, we sub in our height equals 8, simplify everything in the brackets. So obviously 0 times anything is going to give you 0. And from here, you're just solving a regular old circular function. The way we solve circular functions, if you haven't already seen it, is you start by rearranging to get that circular function on its own. So that means, in this case, subtracting 5 to both sides and dividing by 3. So it's going to give you, what, 3 on this side, divide by 3 gets you to 1. We just want to know, where is sine equal to 1? This is where you have to use your unit circle. So I know a lot of people are very averse to memorizing their unit circle. You will get this question wrong if you don't know how to use your unit circle. And this will be something that's on a tech free. So please, for the love of God, study it. And but for those who haven't immediately solved what that's going to be, you can use reference tables like this that I have in the community. So the way this works for, you know what, I'll go down a bit. This is what you'll eventually have to have memorized. There are ways of memorizing this better. That's a topic for another video though, so maybe check back the old classes or the ones that I've already pre-recorded for that. So how does this work? Solving sine of epsilon is equal to 1 simply means, where is my y value equal to 1? Sine is on the y-axis, cos is on the x-axis. Only y value equals 1 is up here. For the guaranteed angle there, that's going to be pi over 2. Right? The only way you can get up here is with the angle pi over 2. Technically speaking, you can go multiple times around the unit circle. You'll get the right answer still, but you look a bit crazy if you go multiple times around the unit circle. So just make life easy, pick the first valid solution there, and then slide it into where it belongs. So plus epsilon plus pi on 2. That would solve that question exactly as presented to us. Now, if the question was slightly different and didn't really give you any guidelines as to what your circular function should look like, or for whatever reason you've picked a different way of going about it, you can use the trig identities to rearrange your circular function. One of which being the fact that if you added pi over 2 to sine, you would turn it into cosine. And so this is what I mean by fixing the circular function. When you add a horizontal translation to a circular function, you can rewrite it in terms of a different circular function, or even change the number altogether. So to highlight what that would look like, I'll bring out the CAS for the handwritten notes section. Or not, because the CAS has decided to die. Alright, we'll come back to that when it's loaded. Point being, you can use these trig identities to rewrite things. So because we had a plus pi over 2 here, you can drop the sign down to a cosine and then just remove that pi over 2. And now it looks a little bit nicer. So in summary, we pretty much follow this kind of framework. It isn't the be-all, end-all of how you do things. This is just the order in which tends to be easiest to do things in. So I'll put that summary in the chat there. If you have any questions as to how, whenever someone sends me a thing, I immediately get it direct to them in the chat. Okay, that should now be in the group chat. Cool. So I've just done a screenshot of the summary, the kind of frameworks that you'll be using to solve these things. Any questions, please leave them in the chat. Otherwise, we can get into some textbook questions while my CAS decides to fix itself out. Oh, look at that. It's working now. So I guess before we move on to exactly those questions, I just want to show that identity there. So if you have sine of x, it would normally look like this. If I then were to plot sine of x plus pi over 2, you would expect it to shift left by pi over 2, and sure enough, that's what happens. If I then overlay that with the cosine, you'll notice that the green line has perfectly overlapped the, I think it was pink before, whatever it was. And so because those are mathematically equivalent, you can write any of those. Okay, so that's that. Is it 6L applications? Determining rules. Okay, yeah, we'll do 6L. Okay, this one will be a bit more interactive. I'll actually ask you guys how we solve it, and then using either the framework or your own understanding of how this works, we'll see if we can put these questions together. Okay, so to the screen share, we're looking at 6L. Does anyone have any trouble reading that? If so, I can do screenshots in the chat, and it's probably a bit easier to read it from there if you have any trouble from the screenshot. But okay, let's have a read of question 1, and pretty much all we want to do is answer a few key questions about this. Namely, can we get the amplitude, can we get the period, so on and so forth. Well, we'll start from the top. First things first, how do we know the amplitude of our circular function?
So usually the trough of like sine x would reach 1, and from 0, which is just +1, right? So since this time it's reaching 5 from 2, we can see the trough is 3 units high, so that means the amplitude is 3.
Trough is 3 units high. Well, trough is actually going to be like the absolute bottom here.
I mean, sorry, the peak, sorry.
Yeah, okay, so you're talking, well, the peak is 5, and the trough is 2. You're talking to the middle?
No, like, oh, wait, yeah.
Because
No,
the difference between these two is 3, yes.
yeah.
But
5 minus 2 over 2. Yeah.
Say again? Are you trying to do the middle?
You do like the peak minus the trough over 2, which would be
it's the addition and then divide. So 5 plus 2 divided by 2.
yeah.
But yes, that'll be the amplitude. It'll be the middle of those two. Another way of doing it, what you did before was the you did the difference, and if you were to halve the difference, you'd get 1.5, and so you could add 1.5 to either of these. That's another way of doing it. Difference, halve it, add, or you could just do add and divide by 2. Both of those will get you to what you're looking for, which is an answer of 3.5 in this case. So let's write that down. We'll have A equals 3.5. Oh, sorry, 1.5. What am I saying? Oh, right. Okay. No, I've confused what you were saying. Amplitude, 1.5. Middle is 3.5. Sorry. So what are we going to call the middle? We'll call it C. C equals 3.5. Okay. Cool, we have that. Next up, double I, is the period. So what's that all about? anyone remember what it is by definition rather than by this particular question? Okay, let's have a look. So by definition, the period is how long it takes the circular function to complete one cycle. Now that can be peak to peak, it can be middle to far middle, it can be trough to trough. It doesn't actually matter where you start as long as it does one complete cycle of the circular function. For those interested, it's calculated by 2 pi divided by n. We don't necessarily need that for this question. We just need to know how long does it take to complete one cycle. So looking at this picture, how long does it take to complete one cycle?
12 hours?
Yeah, 12 hours, exactly. Because even though you're seeing two wave patterns, because it only repeats in that half wave, yes, you would give t equals 12 there, or capital T equals 12. There you go, capital T equals 12. Triple I, this is where we now have to put all our information together. So what you might notice is we've kind of done things a bit backwards. You notice how it was slightly difficult to calculate the amplitude, a bit easier to do the mid-level, and the period was pretty easy. You could just look at it once you know what you're looking for. Okay, how do we now put that all together into a rule for d of t? This is where it gets a little bit trickier because there's not a whole lot of guidance here. How could we start it?
I see it's a trough at the bottom.
Yep.
So we're at the y-axis, so I think that's a sine graph.
Could be either. Could be either.
It does say the function d is sinusoidal, so I don't know what that means, but I assume it means sine graph.
Okay, no, that's fair enough. Sinusoidal is it's more of an engineering term or a physics term, really, that talks about the family of functions that is sine and cosine. So that's talking about both, technically speaking. And as I said before, sine and cosine are more or less the same thing. They just, the terms look slightly different to make them look the same, but you can go from one to another, provided that you're putting the right information in there. And so whether you pick sine or cosine to start with here doesn't really matter, but ideally you would try to pick one that doesn't require any substitution to get horizontal translations. So under this circumstance, because it starts at a trough, if you compare the differences between the basic sine and the basic cosine, the basic sine will always start at 0. The basic cosine will always start at a peak. So the way to memorize this the way to apply this to application style questions is if you can observe that your circular function starts at the top or at the bottom, you have a cosine. If it starts at the top, you can consider it to be a positive cosine. If it starts at the bottom, you can consider it to be a negative cosine because it's got a trough value instead of a peak. So this one would be easiest to start with a negative cosine. That being said, you can still solve with a sine anyway. But okay. So we're going to have something like a cos n bracket t minus h plus c. So that's a generic cosine with amplitude, period, c, horizontal translation, that sort of thing. What can we then do now that we have a starting point?
Substitute?
Yeah, substitute some values. Yeah, no worries at all. Now, this is where choosing the circular function is a bit important. If I just say a equals 1.5, well, no, it'll still be fine. You would just have to choose a h value. But the whole goal of choosing cosine was to make life easier for us, so we don't have to choose a horizontal translation. So the fact that our cosine starts at a trough is going to mean that we're going to take that 1.5 and make it negative, just so we don't have to have a horizontal translation anymore. N, we don't know yet. T, and then the whole point of this was to get rid of h, so we can ignore that. A c is always going to be whatever c is, so plus that 3.5. Okay, so we've knocked off a lot of those. Only thing left is n. What are we going to do to get n?
I can't remember. N is which part of the graph again?
N is no specific part of the graph, but it is used in the calculation of a part of the graph. And that is that, where is it? Period. There it is. So period, yeah. Thanks, Yapraj. Using the period calculation, yeah, 2 pi divided by n. So to see what that looks like, you'll have a certain distance. We figured that one out earlier. For us was going to be 12. That is our period, capital T, which we can then substitute into our equation. To show what that looks like in the previous notes, we did it, well, we've actually done this exact thing, right? Period was 12, just like ours is. Equate it to 2 pi over n, because that's what the period calculation is. N is the only unknown in there, and thus you're going to get pi over 6 as your n value. So putting this all together, minus 1.5 cos pi over 6t plus 3.5. And you'd have to call this d of t. It does specify give the rule of d of t, which is why I've used t as my x value rather than just x. If you are aiming for those higher grades and those higher study scores, you will have to be very specific with what you call your variables. If you're just doing a whatever test, like most of the time your teacher's going to look at it and think, okay, that's fine. But if you're at a maybe high performing school or want to yourself perform quite well, these are the things you should consider. Okay, now here's a weird thing. There was a story behind this. This was the graph of a clock's, the distance between the large hand of the hour hand of a clock from the ceiling. That's what this was depicting in terms of, what was this in terms of? Meters? Meters. What is the length of the hour hand? Interesting question. I'll just be drawing a picture while you guys have a think about that.
Is it not just the amplitude 1.5 meters?
Yeah, sure is. Amplitude. Can you explain why it's the amplitude?
Because the closest point is 2 meters. That's the trough. And the crest is 5 meters, which is the highest point. So if there's at the minimum 2 meters gap, then you effectively remove that and then you just look at the distance between the crest and the trough.
Mm-hmm. Yeah, precisely. This is moving at a certain speed, doesn't really matter what the speed is, but you can see in the two pictures, depending on where the hour hand is, your d value will either increase with respect to the ceiling or decrease with respect to the ceiling. And the length of that hand is going to be how, the length of that hand is going to dictate how much it'll swing up or down. Nice. Okay, and then part B is a pretty classic, just sort of whatever question. At what times is the distance less than 3.5 meters from the ceiling? So you have your graph here. This is less application, it's more solving circular functions. But we'll still do it anyway. Any thoughts on, even if we don't like solve it, how would you go about doing part B?
with this question, is it asking like what time is it specifically asking? Because because it's asking the general time. So would you just say like uh hour zero to hour to hour like I think 3?
Yeah, so you're talking about like this spot here, roughly?
Yeah, that those spots, and then
Yeah. Yeah, you would give it in terms of that. There is no like T
it's a bit
hours.
vague.
It is like, yeah, it's vague. Like you could assume AM PM stuff, but technically speaking, you could set your reference time to whenever you wanted to. It's still just a 24-hour period. It is a clock. Maybe that can help with your understanding of what the time would actually be. Would I say midnight to 3:30 AM? 3:30. Oh, right, because of this spot. Yeah, okay. Whatever that ends up being, if it was 3.5, wait, would it be 3.5 or 3? Yeah, whatever this ends up being, that will be part of it. You also want to include these as well. So you want to include this distance of time here, and then this distance at the very end that you want to also include. So you want to have all of those lined up. Right, what I was saying before was the fact that this is a clock, right? And so you can kind of get an idea of what it's going to look like. Like this should be pointing directly up because this is the minimum distance between the ceiling and the hour hand. And so that should mean that your hour hand, if you look at the handwritten bit that I'm poorly drawing, the hour hand should be pointing directly up because that will minimize the distance between that and the ceiling. And so from that way, because this is a clock, you could give it in terms of actual times. I don't think they wanted you to go that deep. I think they wanted you to just say the time in hours, like t equals what to t equals what. But okay. That's that. Question 2 is going to be very similar to kind of what we were talking about, at least as far as an application goes. But in this case, we actually have the full circular function. So t is the number of hours again, d is the depth. We're kind of familiar with this from the previous example we did together in the written notes. Sketching the graph, that's a bit beyond the prior scope of the previous classes. Sketching a circular function, if you want to read up on that, there's this document here, document 7, that goes into all the detail as to exactly how you do that. Just for our interest, we're going to save some time and just focus on how we can interpret these graphs. Okay, so handwritten bit now, I'm just going to be copying over the circular function. 6 plus 4 cosine pi over 6x minus pi, pi over 3. Okay, well, I thought that was a parabola for a second, just a bit off screen. So we have a 6 and 4, I don't know, let's cap it out at like 15. And we're doing this from 0 to 24 as per the question. So you put in x equals. Just for our visual, I like to go a little bit backwards and a little bit forwards of that domain, just so you can see the full scope of what you're doing. And if you do want to cut it off to make it more accurate, you can put that domain in here instead with a vertical line. Obviously, I'm doing this with just the TI Nspire. The syntax is the same on a Casio. If you have this one here, it'll just be in a different spot. But the actual buttons, not the buttons, sorry, the actual text that you're seeing will be the same wherever that's located. But okay, so we wanted this one from 0 to 24. If you want to, you can be very, very pedantic with using the correct inequalities, but as far as the CAS goes, as long as you're getting the numbers right, it doesn't really matter if you're including or excluding the point. So, and just like that, you'll have a nice look as to what your graph will look like. A little bit before, a little bit after as far as domain goes, and you get to sketch it over whatever it should look like. Okay, that's part A done, sketching the graph. Part B, what is the earliest time of day at which the water is at its highest? Maybe I will screenshot these just so I don't have to go through too many windows. Maybe it'll be easier to look at the chat instead of sliding windows. We answered a pretty similar question, literally last question. Similar vibe. Okay. So, if we're using a CAS to solve this kind of question, what you might want to do is just use the graphing tools. So, both CASs have graphing tools for the TI Nspire. Yeah, Sanjay, that's correct. You look for where the peak first happens, and that's what we're going to be doing with in this case with the graphing tools, but you can also solve it by hand, which we'll have a look at briefly. Menu 6, now because we're looking for maximum, we'll click maximum. This will be a little bit of a slider. You just click once on one side, once on the other side, and that's going to give us t equals 2. You know it's this one, not this one, because time is on our x-axis. So earliest time of day, this one you could give in terms of an actual literal time, because you're told that t is the number of hours after midnight, so you would probably give 2 AM for this one. Now that's CAS using the graphing tools there. You can also solve this. So if you want to solve, well, when I say solve this, I mean by hand. If you wanted to solve how this looks like by hand, you would have, well, first things first, let me just write out the function. D of t equals 6 plus 4 cos pi over 6t minus pi on 3, and that's the whole thing. Okay, so we want to know what's the earliest time of day at which the water is at its highest. What is the highest value, or the highest depth of water? Reminder that this is a function of depth against time, so depth being on your y-axis and time being on your x-axis. If we're looking at the CAS, or otherwise, how would you know what the maximum depth is?
Is maximum depth just the peak?
The peak, precisely, yeah. Feels a bit weird, right? When you think about depth, you usually think going downwards. But because depth is a value on our y-axis, depth increases as it goes up and decreases as it goes down, at least as far as our thing looks. Bit weird, but yeah. So that's how we could solve it via CAS. If you just want to use, or if you have to do it by hand, it's just going to be that. So if you think about how circular functions work, they start at the middle and they go up and down by the amplitude. 6 plus 4 is 10. Now, that gives us a depth value. We know that d equals 10. All we have to do is solve for the time, t, at which that happens. 10 equals 6 plus 4, all of that. Subtract the 6, divide the 4. 4 divided by 4, 1. So we want to know where cosine pi over 6t minus pi over 3 is equal to 1. This is a bit of a complicated circular function because it has a bunch of nastiness in here. If you want to review exactly how that all works, in more detail anyway, please be sure to check, which document is it? Let me show. Document 4. So solving circular functions. It goes into the exact procedure we go into that. I'll run through it briefly, but be sure to just check that up in the classroom. Okay, so first thing you want to do is just replace everything in here with a dummy variable. So we're going to have cosine of u is equal to 1. Where is cosine equal to 1? Well, if I get the unit circle up on the screen share, you'll see because cosine is x, we're talking about the coordinate on the far right-hand side, which means an angle of 0 radians. That means u equals 0, because we're looking for the first possible time. And so if u is equal to this, then what we can say is pi over 6t minus pi over 3 is equal to 0. From here, we're just rearranging to get t on its own. Pi over 6t equals pi over 3. Multiply, well, cancel the pi's, and then multiply both sides by 6. T equals 2, as was found on the CAS. That was brief, yes. Just have a read of specifically, where is it? Specifically example 4 of this document. It details exactly what we're doing and why. Okay, that's that. That's part B done. Okay. Part C. When is the water 2 meters up the wall? Oh, that's nasty. Depth of water. When is it 2 meters? See, that's a tricky wording. Because D is depth. And it says 2 meters up the wall. Those are the same thing. Whatever your depth value is, will be how high it goes up the wall. Because if you think about water can't go down, right? There's a sea bed. It can't go any more down, and so to increase depth, you have to go higher, right? The waves have to go higher. So when it says when is the water 2 meters up the wall, it means when is the depth equal to 2. Very similar question to what we just answered. How do you think we solve it?
You just look for the y equals 2.
Y equals 2, correct. If you're doing it on CAS, you can put that in a solve function. Let me just double check. Okay, this is function 13. So you can put that directly in a solve. Menu 3, 1 on the CAS, on the TI Nspire, I should say. I have a lot of functions, geez, I really need to fix that. Function is equal to 2, comma, x. If you just hit, oh right, I did put a domain on this, never mind. Usually if you just hit enter on a circular function, it'll give you infinite solutions. I was already jumping the gun on that by putting a domain on it in advance. So what this is telling you are the time values, plural, in which case you have a depth of 2. Visually speaking, if we draw y equals 2, it'll be that spot and that spot. So if I draw the relations there, which is menu 3, 2, and then drawing x equals 8 and whatever the other one was, x equals 16, maybe? Not quite.
It was 20.
It was 20? Cheers. And so if you draw both of those relations, you'll see, of course, it's going to intersect at that spot. That's what you're graphically finding. As for how you would do that by hand, this 10 becomes a 2. That's it. Now, it might make the rest of this more complicated, but you still follow the same steps, where you rearrange to get the circular function, dummy variable, solve for where is it equal to 0, sorry, where is it equal to whatever this is, rearrange, solve for t. Okay, that's that. This one we went through together. Same question, same question. This one's talking about a particle. Yeah, this one's probably on the harder side because of the story behind it, rather than because it's actually like mathematically difficult. Okay, so I'll do a screenshot of question 4 if you don't want to look at the screen share. Have a read of that. This one's a stranger one for a couple of reasons, one of which being the fact that x is on your y-axis and t is on the x. So your function is x of t in this case. But it is given to you, which is good. Have a think about what's going on and see if anyone can answer 4A.
So it's the peak of the.
Yeah, you're on the right track.
I'm just thinking, 'cause it feels like it's not a circular graph. I think I'm misreading the question though.
It is definitely a circular function because it's
There
got
it
the
is, 'cause it's
cosine in it. Oh, sorry, the sine. Yeah, you're on the right track. So what would that?
So it's the peak of the graph because that's the furthest point from O, right?
Correct. Yeah, because this is a function that's depicting so your x value on the y-axis is the distance relative to O. So bigger number means further away from O. What is the peak in this case? How would you know?
Sorry, did you say how do we know it's the peak?
No, what is the peak? How would you know what the peak is?
Because it's plus or minus 2.
Yeah, so plus or minus 2 is where it goes with respect to the middle.
Yeah, and I think the middle is 0.
Middle's going to be 3 in this case.
Oh,
So when
is
you
it
have
3?
even though there wasn't a plus on this side, you're still adding a 3. It just happens to be on the left instead of on the right. So because of this is, yeah, peak is 5. Thanks, Supraj. Because you've got a middle of 3 and you're going plus or minus 2 from that, 3 up to 5, and 3 down to 1. Hence the greatest distance is going to be 5. Someone can tell me, part B, what's the least distance therefore going to be? Yeah, that's correct. Amplitude is 2 and translation of 3. Yeah. So with that understanding, what would the least distance be? We've done greatest.
If it's translation of 3, so it becomes 1 because it's 3 minus 2.
Yeah. Easy. Okay. Find the times at which it's 5 meters. Find the times at which it's 3 meters. These are effectively the same question. We've done 2, maybe 3 examples of this. Who can tell me how we would do this, at least conceptually? We're actually looking at the solutions to one of them on the handwritten notes.
I think you want to find the peaks inside the domain. I think
Mhm.
like I'm not sure because I'm new to this topic, but I think the 3T means like the graph got like 3 times condensed in the period.
Sure does. Yeah.
And yeah, so you want to basically find the first peak, which is if this is a sine, it would be 5
Mhm.
5 and pi over 2.
Yeah, so the relative location of it on the unit circle will be pi over 2. That's correct. And then, as you said, because it's 3 times condensed, what you effectively do is divide that by 3. Yeah, that's exactly right. Nice. So, mathematically speaking, what you would do is, if you're looking at the thing we did on the handwriting, we started that one off by equating it to 10, since 10 was the max. In our case, 5 is the max. And if you do rearrange that, you will just get to circular function equals 1. That's going to get the pi over 2 spot. 3, a little bit harder, but not by much. If you rearrange that one, you're going to get just the middle. So when does sine hit its middle? Middle is going to be like a 0 value. Since sine is the y, it's going to be either 0, pi, 2 pi. You want to pick the earliest ones though, because you're doing it specifically between 0 to 3 for t values. So you pick whatever still fits in that domain. Now here's a weird question. Describe the motion of the particle. you've got a graph that tells you, or I guess a rule that tells you what the particle is doing. How would you describe that physically speaking? I'll start drawing a picture, and we can play a bit of, I think it's called Pictionary, when you draw a picture and people got to guess what it is. We'll play whatever that is. Who can get it first?
I mean, it's saying the particle moves in a straight line.
Yeah.
So it's just oscillating back and forth from position O, right?
Brilliant. Yep. Well, with respect to position O, to put a bit more nuance on that, because we have a minimum distance of 1 and a maximum distance of 5, the particle is going from here to here, and like your origin will be like this spot here. It's going back and forth in a straight line, back and forth. It's a weird thing to think about, because you've got a graph that looks something like this. You've got straight line motion, which usually means shoot off in one direction and don't come back. The way you marry those two things together is to say, actually, even though it's going in a straight line, it can go back on itself. Nice for identifying that. That's usually pretty hard for most students. Okay, that's probably one of the tougher ones, so we're pretty good so far. Let's see, which of these would be better to do? Temperature at time, whatever that is. Sketch the graph of... Oh, because you've got two different... Yeah, okay. That could be complicated. How about this one? In degrees. Yeah, both are about as complicated as each other. Let's just stick with 5. Okay. I'll put that one in the chat again. Have a read of it while I do that. So we've got two different circular functions, and they are depicting, or I guess you could call it measuring, the temperature inside of a house. For this one, A is inside the house and B is outside the house. How far outside the house? I guess is whatever, up to interpretation. I guess point being, you got an inside and an outside. And then part A is just what is the temperature inside the house at 8 AM.
So I think they say T, so do we just substitute 4? Because it's 8 minus 4, right?
Good, exactly right. T is starting at 4 AM, and so because you're doing 8 AM, that would be a T equals 4. Which equation? B or A? Which do you sub into?
A.
A, yeah. Since A is talking about the temperature inside the house, then that's the one that you care to sub into. This one here, you could do by hand. It wouldn't be the worst, because this will be, what's that, pi over 3? I think so. And pi over 3 is an exact value on the unit circle. It would be this spot here. So you can go through, but it's no different to what we were just talking about, which is plugging things into here. So same rule. Okay, B is a bit interesting. Write down the expression for D equals A minus B. What does that look like? Even if you don't have like a specific answer, how would you go about answering it?
Could you use like a common value for both the expressions? Like sub in like, let's say 1 for like T is equal to 1 for both of them?
Okay, after you sub in T equals 1, what do you do from there?
Just subtract the two expressions, I'm guessing.
Yeah, exactly. Now, that would be a perfect answer if all you didn't say was sub in T equals 1. You ignore that first bit of subbing in a T value and you just go for the expressions as they are. So you would literally do this whole equation minus this whole equation. So you'd have your 21 minus 22 giving you minus 1. you've got a -3 cos and a -5 cos. When you subtract the two, you should end up with like a +2 cos, since it's -3 minus -5. So you just go straight for the expressions rather than subbing in a t-value. So I guess the lesson there is don't necessarily be afraid of having... one thing you can do, mathematically speaking, is grab entire equations and subtract them from each other. You actually already know this from doing, well, I hope you've done elimination method before for like simultaneous stuff. You can do full operations on entire equations. That's what you're fundamentally doing here. Okay, that's that. Sketching the graph, whatever. Just plot it on CAS or sketch any other circular function like you always would. Again, if you need to read up on how that would be, the specific section would be, yeah, on the tougher side. It'll be the vertical. So this, where is the example? Oh, I don't actually have these labeled. Weird. Followed this. So this page is talking about the vertical translation from document 7. Okay. Determine when the inside temperature is less than the outside temperature. Okay. So for that, we'll get a picture. You would have already sketched D, so what I'll do is sketch that myself on the handwritten bit. Oh, sorry, on the CAS, and we can interpret that. So what did I say it was? It was -1 plus 2 cos. Yeah. 2 cos pi on 12x. You can put a domain on it. Why not? X less than equal to 24. Set our domain appropriately. Okay, so that's the information that you would have had from C, and you have to use that, or otherwise, to figure out when is the inside temperature less than the outside temperature.
So when it's cos pi by 12,
Mhm.
if they're both pi by 12, then you don't worry about it. But if they are different, like if it was pi by 6 and it was pi t by 6 and then pi t by 12, what would you do in that instance?
You would be in a specialist math class, is what you would be. There are rules for it, yeah. It's, just for interest's sake, I'll Google it. I think it's sum of cosines. Sum of cosines. Let's see, do I have it? Yeah, okay. I'll do a quick shitty little screenshot and just show you. There are rules that you can use to rewrite things in all sorts of fancy ways. I'll put that in the chat. Where alpha and beta there are different angles, like you're talking about pi over 6 and pi over 12, for example. You could rewrite those with the equivalent right-hand sides. Good question,
right.
though. It is a special thing, but good question nonetheless. But as for this one, determine when the inside temperature is less than the outside temperature. One thing that would be worth understanding is, what have I actually plotted here? What is D? What is D actually telling me?
The difference of T?
The difference of T. Now, which way is it? It's the difference between the inside and the outside. So if you want to know when inside is less than outside, what does that tell you? What would your D values likely be for when it's inside? When it's if you want inside to be less than outside, what would your D values be?
Negative?
Yeah, negative. Where is it less than 0? This is a graph of D. Because your difference is with respect from inside to outside. If that difference rather is negative, then that's what those t values. So you just want to know where is this graph negative, which means you want to find basically the x-intercepts of your graph. So subbing in y equals 0, or use the graphing tools, whatever would be required. And then it's just this interval from here to here, which, peeking at the answers, would be from 4 to 20. And you can kind of see the ticks there. Yeah, that's that. Now, as far as how you give the final answer there, you'd want to use rounded brackets, because if you use square brackets, you're saying including that value. We don't want to include it because that's not less than 0. Well, that's not a less temperature, it's less than or equal to temperature, which we don't want. This question was just saying less than. Clear enough on the brackets? Okay, so that is that. I mean, we have hit time here. There is obviously one more question to be done, and it is on the tougher side. Don't imagine it being too much tougher than that. Only thing that's a bit weird would be the degrees. Yeah, so if you want to continue with this sort of stuff, you can finish off question 6. You could go to the chapter summary and do some of these extended responses. You'll see clocks, you'll see tides, all the sorts of stuff that we've already had a look at. Okay, that is that for this lesson. I hope you guys enjoy the rest of your day. If you have any questions, feel free to stick behind for a moment. Otherwise, take care.